Hello, my backyard astronomer fans, and welcome back to Curiosity Studios at the Pacific Science Center in beautiful downtown Seattle. I am so thrilled to be joining you all with another virtual planetarium tour of what's going on in the nighttime sky. And we've got exciting news today. Tomorrow morning, NASA hopes to be launching a new mission to the planet Mars. So we're going to talk a lot about that today, but really I want to explore a lot more of the missions that NASA is doing, particularly when it comes to something called astrobiology. This is studying the biology of the stars. This is looking for alien life out there, even in our own solar system. There's a big question about whether or not there is life outside of planet Earth, and there are a lot of missions out there to kind of explore to see if that's really true, that's really possible to have life outside of Earth. So that's why we're starting not inside the planetarium today, but I have this adorable, look at this thing. It is absolutely cute. How adorable it is. It's the tiny little feet. I like the tiny little feet, personally, like right there. It's got that really big mouth. This is an image of what we call a tardigrade. It is a water bear. So basically, this is an extremophile. It's a type of animal that lives in extreme environments. And so just like with any other virtual planetarium tour, I would like all of your participation and throw that up into the comments section. I have a friend named Zita. She's also on the chat. She could help answer some of my questions, some of your questions, and bring them up to me. And it's really, really kind of fun if we explore the planetarium together. In the meantime, here's a really good question for you. Can you imagine seeing, where do you think you might find an animal like this on planet Earth? Go ahead and put your ideas and your thoughts, and I'll shout them out, put them on in chat. Where do you think you might find a tardigrade on planet Earth? And I'll give you a hint. They are nicknamed the water bear. Normally, they're microscopic creatures. That means that we can only really see them with a microscope. And you can see how it might chow down on some vegetation. Oh, we've got some people who think that they might be found in Antarctica, maybe in those deep, cold, watery places with some vegetation growing down underneath Antarctica, underneath the ice. That's a really good guess. But really think about that water bear. One of the things that are really special about these things, Jack, age 3. He thinks that you might be able to see a tardigrade in your backyard. And that's extra true if you think that backyard includes an ocean. Let's say you live in Des Moines or in Kitsap. Some people say it's in the rainforest. Some say it's in the ponds. Absolutely. These are all fantastic answers. This is great. And I notice a common trend with all of your answers, everyone. A lot of you are thinking because of water. That's where these things really love to live, including water and ponds in your backyard. Nice job, Jack. That was a great answer. But yes, they could also be found in oceans and on coasts. They could be found in rainforests. They could really be found all over the world. And I bet they could even be found in Antarctica. Because here's the thing about these tardigrades. These things are survivors. They can have survived in boiling water. They have survived being frozen. They have turned themselves off for decades and then warmed themselves back up, and they came right back to life. These things have even survived being outside in the vacuum of space. They have lived in outer space, even without an astronaut suit and anything. These are extremophiles. They love to, live in the extremes. And it's really kind of inspiration for all of the exploration that NASA's doing to places outside of planet Earth, that we might be able to find animals and living organisms, microscopic, really, really small, living in different worlds outside of Earth. So that's really what we're going to be exploring today. And to do that, let's start off by going back to our planetarium. This is our planetarium. It's our daytime sky. This is what things might look like from here in Seattle and at what time it is right now. We've got a great question from Chris about, can we send these tardigrades to Mars? And what do they eat? They love to eat plants, kind of like this big leaf behind me, and algae, and really, really tiny microscopic cells. They have their own cells and they just kind of gobble that stuff up. The question is can we send them to Mars? And I want you all to, let's think about that for a second, because sometimes when we send animals to places where they've never been before, well, it could be really bad for that animal. Or it could be really, really bad for that place that we send them. And it could really kind of destroy the environment of that place that we send them. So one thing that NASA works on really, really hard is to make sure that we don't send any living things to Mars until we're absolutely sure Mars doesn't have life. And I'll tell you what, we got the daytime sky out right now, but let's go ahead and fast forward down to night. So I'm going to pop up my time thing. I want you to all observe the sun up high in the sky this afternoon. And remember your observations from last time. Think about it for a second. Which way or direction do you think the sun is going to set? Is it going to set to the east, to the south, or to the west? Let's find out by fast forwarding time. Keep an eye on that sun, and here we go. We're going to fast forward. Oh, it's getting darker. The moon's coming out, and it's already a half moon. It's going to be really bright tonight. Oh, friends, look how beautiful it is at 10:30 tonight. Nighttime sky looking due south, close to the horizon. We have a half moon, and we have two giant planets, Jupiter and Saturn. And just to make sure that they really pop, I'm going to turn off our atmosphere, make it really dark. So friends, there have been missions to Mars to explore to see if Mars has had life in its past. But there's been other missions to explore the possibilities of life, including missions to Jupiter or Saturn. And I want to ask you all, go ahead and vote on chat. Which of these planets and missions do you want to explore first? Do you want to explore Jupiter? Go ahead and type in Jupiter. Or do you want to explore Saturn? Go ahead and vote, and I'll answer this question about Neowise. Neowise was a great comet. It was up to the north. In fact, let's go ahead and navigate to the north just really quick while you all vote whether or not you want to go to Jupiter first or Saturn. There's Neowise. Neowise is a beautiful comet. It's still kind of out during the nighttime. You can still kind of see it, but it's getting really, really far away as it goes into the far distances of our solar system. It's even starting to lose part of its tail. Its tail is starting to shrink. But if you wanted to see Neowise out tonight, because there's going to be a beautiful clear sky, again, you're going to look towards the northwest, the west-northwest this time. Look for the Big Dipper. Those 7 beautiful stars, the 7 sages that make that spoon. But instead of just opening up the bottom and letting the water out, this time you're going to use the handle. And the handle is going to arc to Arcturus. You're going to see a big red one. And it's kind of forms a triangle between the tip of the handle of the Big Dipper, Arcturus, and Neowise. But at this point, we're going to need some binoculars and or a telescope to see it in Seattle, or go to a really, really dark place in the sky to see the comets. In the meantime, I'm really excited about those planets. And I am, along with Laura, Judy, and Paulina, I am ready to go explore Jupiter. So let's go ahead and do that, and let's do a 3, 2, 1 blast off to visit Jupiter. All right, here we go. I'm going to pop up a different screen now. I'm going to pull up our navigations in our little spaceship here, And we are going to explore Jupiter, and let's just go ahead and fly in that sky and go. Oh, look at that. Oh, Chris wanted Saturn, and don't worry, Chris, we'll go to Saturn next. But in the meantime, let's explore Jupiter. Look at that giant planet. Absolutely the biggest planet in the sky. Brightest planet out in the sky today. Now that Venus is sitting a little bit early. We're a little bit sideways, so I'm going to try to see if we can navigate around and kind of spin around to be less sideways. There we go. Awesome. And let's go ahead and zoom in. Here's the thing about Jupiter. Jupiter is a big gas planet. You see all of these clouds? Well, all of those clouds on Jupiter basically are giant storms. And so we're not expecting, it's not impossible, but it's not expecting to see a lot of storms on Jupiter. But we have sent a mission to learn more about Jupiter. So let's go ahead and explore what that mission is. Oh, this is Juno. Juno is a space probe that we sent to Jupiter in 2011. It's exploring its magnetic field, its atmosphere, and its core. And that's because we're curious if the magnetic field could protect Jupiter and any life that's around it, maybe on its moons, from the sun. And there's other things that this giant probe is going to do as it goes to the planets. But just to give you an image of how good this probe is, that's Jupiter. That's a close-up view of Jupiter. You can really see the storms now. It's absolutely gorgeous. Beautiful storms swirling around. And it's a mixture of those chemicals and storms moving that energy that life really, really likes. That's one of the things that we look for in a planet. It's how does it move energy and chemicals and other building blocks so that animals and vegetation and life can capture that energy. Now, I don't think we're going to be able to find anything on Jupiter. But just like the Earth has a moon, Jupiter has a moon, and it has a very, whoa, ladies and gentlemen, I think I just crashed our little space machine. Let's zoom out and move away from those clouds. And let's get our navigation system ready. We're going to pull up a very special moon around Jupiter called Europa. You see, the Juno mission not only is exploring Jupiter, it's exploring its moons. And this is a very special moon. We are really up close to Europa right now. Oh, and I think I spun it around. And go ahead and share on chat if there's any observations you have about Europa that you want to share with anybody there on chat. Whoops. Let's move you right back up. I can't believe we almost lost Europa. We almost flew our spacecraft way too high. One thing I'm noticing, maybe you're noticing this too. Do you see these long stripes? I wonder what those might be. Go ahead and put on chat what you think these long stripes along this moon might be. And notice how bright it is. Oh, wow, and the stripes go away after a while. But it's really, really bright on Europa. Wonder what is covering Europa. What's on top of it? That's a really great question to explore. Go ahead and put on chat what you think Europa might be covered with. Chris thinks it might look like ice. I think that's a great observation. Polina, Jupiter has the second most moons. It has over 79 moons. A lot of them had been just discovered in the past 5 years. Awesome. And so we're actually still exploring how many moons Jupiter might have. It might have even more. Those cracks, well, let's see, could they be clouds? Maybe they're canyons. If you think about it, think about your observation about Antarctica. Tiger prints from Jack Age 3, that is fantastic, Jack. I really like the idea of them being like tiger stripes. In fact, anytime you think of Europa, Jack, I want you to think that Europa has tiger stripes. These are a lot of great observations. The answer is we think they are so bright and that these long strips are cracks in ice. We think Europa is covered by a giant glacier, just like Antarctica. And there are parts in this glacier where cracks are formed. And that's because this ice is constantly moving. And in order for that ice to be moving, there must be something underneath the ice that moves it around. And if you think about an iceberg, well, what's underneath an iceberg? Friends, we think there's water underneath this ice on a moon that goes around Jupiter. We think that there's so much water on Europa that there might be more water on this moon than all of the oceans on planet Earth. And so there are missions that we are even planning right now to maybe one day drill down into this ice and go ice fishing. I think that would be an incredible experience, but it's going to take some planning and it's going to take some ideas. And that's a special thing that I'm really excited about, is that they're even planning a mission right now called the Europa Clipper to directly look into those oceans that's underneath this ice around this planet. Let's see if we can even get a picture of that planet, of that mission. Going around Jupiter. Oh, there it is. That's the Europa Clipper. It's another satellite just like Juno. It'll go around the top. It won't land just yet, but this is the first step of exploring more about Europa, the ice that covers it, and maybe the water underneath. And then, after this mission, maybe then we could land on Europa and explore more by drilling into that ice. In the meantime, there's a lot more planning. This mission is not launched yet, but we're hoping to launch it this decade in the next few years. All right, that was beautiful Europa, and we're looking for life there. But Chris had voted that we go to Saturn and see if there's anything about Saturn that might give us signs that life might be living around there. Are you all ready? All right, let's take our spacecraft and we are going to set in our navigation system to Saturn. Ready, set, go. If Jupiter was the biggest planet, Saturn is the second biggest planet. And we had a big question about how many moons does Jupiter have? Even though Jupiter is bigger, it turns out Saturn has even more moons. It has 82. And a lot of those were just discovered recently too. So we keep on finding more and more moons around Saturn. Saturn even has moonlets, tiny little objects that are smaller than moons that still circle it. It's got about 150 moons and moonlets circling it all the time. Now, just like Jupiter, Saturn is a gas planet, and there might be things happening in the clouds and the atmosphere as the energy gets moved around. But just like with Jupiter, it's not the planet that we're interested in. It's its moons. And there are two special moons that I want to explore around Saturn. The first one is the second largest moon in our solar system. It is just outside of Saturn, and it's so big, its name is Titan. Titan is so large, it's even bigger than the planet Mercury. And I want you all to observe the surface of Titan and tell me what you observe about this surface. What do you think is covering up this moon? If Europa was covered by ice, what's covering up Titan? Go ahead and share with Zita on chat if you have any ideas. Honestly, even though it's really, really big, this is kind of looking a little boring. I'm not seeing a lot of details around Titan. Wonder if we got a little bit closer. It almost looks like I'm seeing swirls again. It's like Titan has its own atmosphere, its own layer of clouds covering it. So those who thought like Europa might have an atmosphere or have clouds, Titan is covered in clouds. And you know what? Where there's clouds, what are those clouds might be made of? There might be rain of some sort. And in order to discover that, in order to really see what's underneath Europa, or underneath Titan, let's go ahead and see if I could show you another picture of Titan. Oh, that's what it really looks like. If we peered through its thick atmosphere, if we peered through all of those clouds, this is what Titan looks like on the surface. And what we notice are, well, big, long stretches of plains. It's got mountains and valleys too. Oh, friends, Titan has lakes, giant seas, just like Lake Washington covering the surface. The only difference is, well, we would have to go down there and actually see, and that's exactly what NASA did. It sent a space probe to land on this moon to find out what is going on. This is the Huygens space probe. It was launched in 2011 and landed on this moon. What it noticed is that its lakes are made out of methane. Its atmosphere has a lot of nitrogen, just like planet Earth, but it also rains methane. And it rains in big, thick raindrops, really, really slowly. If you ever had an idea of what methane is like, well, we have methane here on Earth too. It comes in the form of cow farts. It's almost like this moon has giant cow farts for lakes and rains and moves around those liquid materials into gases and into solids to form different types of energies. I don't know if methane's toxic, but I wouldn't want to breathe in a whole bunch of cow farts. I wouldn't want to do it. I don't know if you would want to do it. Are the clouds made out of gas? Absolutely, just like the clouds here on planet Earth. I am really excited that we got to visit Titan and actually land a mission to find out a lot more about this moon. But one of the things I love about Saturn is that it has another moon that adds to the rings around Saturn. And it's going to look pretty familiar after our trip to Saturn. Who launched the probe to Saturn? NASA, the United States Space Agency. So it belonged to the United States. It was a part of a mission called Cassini. Cassini was a probe just like Juno that went around Saturn, and then it had a lander named Huygens that landed on that mission. It was done with the United States, but also in partnership with the European Space Agency. So the Americans built Cassini, but the Europeans, like in the UK and Germany and France, they helped develop Huygens. Huygens is actually named after a French astronomer. Friends, this is Enceladus. This is another one of the 82 moons going around Saturn. Oh, there's a dark side, so you can actually see. Do you see how small the sun is from way out near Saturn? It is really, really cold on this planet, on this moon. And you can see a silhouette of Saturn deep in the background. This moon is actually pretty close to Saturn. In fact, I think it might be okay to move time forward a little bit to kind of get around and see if we could see Saturn in the background. Let it go ahead and mission around. Spin a little bit. While it does, I want you all to make observations. What do you see about this moon? All right. About moons. So, space probe like Huygens and Cassini and Juno, they're all basically giant robots. Robots that don't have astronauts. They go to places that astronauts can't go. So we're not able to make it all the way to Jupiter or Saturn just yet. We can't land on Titan, the moon, just yet as humans, but we can send robots. They are a lot cheaper and it's a lot easier to keep them protected. And they have eyes just like humans in the form of cameras and sensors, and they can land and be safe and send all of that information that those robots see back to humans on planet Earth. Just like Cassini was a robot that flew. It flew around in space around this moon to take all of these pictures to show us different features about Enceladus. And friends, I'm seeing a lot of snow. I'm seeing a lot of those stripes, just like what we saw on Europa. I'm seeing craters. And this space probe even saw volcanoes on this moon. But not like volcanoes that we know on Earth that shoot out lava. This type of volcano shoots out ice. It sends out so much ice, it even adds to the rings around Saturn. And wherever there is ice, we think there might be good signs that there might be water underneath that ice, so that again, there might be life underneath this very special planet. And so NASA sends out the missions to find out more about different places and what it requires to have life outside of Earth. I really like that image because it gives you a sense of what Saturn looks like when you're on Europa. Even, do you see that tiny little line? That's the really thin rings that divide the planet. Now, a little thing right there, that's one of the other moons around Saturn. Oh, that is absolutely beautiful. But I don't have any pictures of Hubble that we could see, unfortunately. All I have are some pictures from, well, I've got some pictures from a really special mission that's going to Mars. One mission is being launched tomorrow. It is going to travel in space for 7 months, and then it's going to land on the red planets. So that's what I want to do next. I want to go see Mars. I want to celebrate what that mission is doing. And in order to do that, what I want to do is show you first where you're going to see Mars tonight as backyard astronomers. Now, backyard astronomers, in order to see Mars, you're going to have to stay up a little bit later tonight, because this is what the sky is going to look like at almost 11 o'clock. But as Jupiter and Saturn move to the south and move to the west, Mars comes into view just below the horizon, just above the horizon, almost due east at midnight. And so in order to explore Mars, I think it is time for you and I to blast off to that red planet. Are you all ready? Instead of just zooming in and zooming in and zooming in to see it, I've got a special program for Mars. Oh, look, it has 2 moons, Deimos and Phobos. That's awesome. But in order to see it in all of its detail, let's pull up some NASA satellite images. Friends, this is Mars. Except for, well, no, friends. Mars is not a flat planet. The Earth is not a flat planet. It's just sometimes when we lay down the pictures, we lay them down flat so they don't roll off our table. So let's make Mars a globe. All right, that's Mars. Mars is a big globe, just like the Earth. And let's go ahead and explore some of its features that I'm really excited about. For example, friends, Mars, just like Antarctica, has ice caps. That's really special. And I'm zooming around, Well, what's this right here? Well, let's look at that. Let's get a little bit closer. A little bit closer. And let's hope that this system is going to take away some of our fuzziness. In fact, let's blast off just a little bit so some of that fuzziness could go away. Oh, and we're in the wrong spot anyway. These images were taken by reconnaissance orbiters. These are just like Juno and Cassini. They fly around the planet and take pictures from above. And this was the object I was looking for. Look at that, friends. Look how gigantic it is. That is Olympus Mons. And that's a really good question about rover pictures. We might have some rover pictures a little bit later. This is a giant volcano on Mars called Olympus Mons. It's 3 times the size of Mount Everest. The last time that this volcano erupted was really, really recently. You see the giant crater where the lava came out and spilled down, building on top of this mountain, building top of this mountain. But then we see some other craters too. Those are impact craters. And the fact that there's so few tells us that this is a really young feature. We think the last time that this volcano blew up was only about 25 million years ago. In fact, I could zoom down really close and get a high details about this. I mean, it's so beautiful. If you had a pair of binoculars, you see how gigantic that mountain is on this planet. You could even see it with a telescope. There's another big surface thing on this planet, and it looks like a giant scar. And that's almost exactly what it is. This is Valles Marineris. It's a canyon on Mars. Why is it red? Oh, that's a great question. Have you ever left your bicycle out in the rain for too long? Think about what happens. The chains start to rust. All of the oxygen in the air starts to bond with the metal in the air. And so that's why it gets this red, dusty surface on it, because it's filled with all of this minerals that kind of rust. The thing about Valles Marineris is that it's giant. It's huge. From there all the way to there is about 2,500 miles. And now to kind of put that in perspective, imagine the United States can fit from there all the way from California all the way to Maine. And it's really, really deep. There are parts of this canyon that are over 6 miles deep. It's formed when plates separate. Let's see if this Mars reconnaissance orbiter could give us a little bit more details of what's below. Let's see, I see those canyon walls, see a flat bottom there, but some more ridges there and a lot of cliffs. Over here on this image, I can see some craters forming on top of the rim of this canyon. Oh, there's more craters down there on the top of the ridge. It's almost like, well, it's just like a big giant cliff right there that's several miles deep. That is amazing. Now, friends, we are going to send a rover to Mars tomorrow. And I want to show you that rover and where it's going to land. So we're going to navigate around Mars just a little bit. And, well, there's the Huygens space probe. That, my friends, is the robot we're sending to Mars. It is all packed up and ready to go. It is going to blast off at 7:30 in the morning, Florida time, to travel for 7 months until it lands on Mars. And it might look familiar to some of you because it's almost a carbon copy. It's almost exactly identical like Curiosity, which we sent a few years ago, back in 2012. This name is Perseverance, and it is going to go explore to see if Mars ever had life. Then it's going to collect some rocks for a future mission to send back. Whoops. it is going to land on a very special crater called Jezero Crater. I'm going to move back to get my orientation of this red planet. All right, so there's Valles Marineris. I'm following this black streak right here. You see, we got planes around Mars, and I'm following the black streak until I see this big bump right there. Right next to it is a plains with, well, not a lot of craters, and we're kind of curious why it's flat there. There's a lot of craters there. That's a little different. But I'm also looking for this big black bump. I'm going to zoom in and zoom in, and I'm looking for this crater. I'm seeing lots of craters. There's one. There's another one. I think it might be this one. Let's go ahead and zoom in on this one. And hopefully my computer can start acting a little bit faster, because earlier today, this was a nice clear image. And sometimes it takes a while for that data to transfer over, because I'm trying to figure out if it's this crater or this crater. I'm pretty sure Jezero Crater is this one. So let's zoom in, get a sense of why we want to land Perseverance on this crater. And we're going to give it some time to actually kind of move in some new images, make that image a lot clearer. Yeah, this is Jezero. Friends, I want you to look at Jezero. Go ahead and share any comments, any observations you have about this crater. What you think this crater, well, let me know what you think this crater got made as we look for some different features. You see, we think that life, it needs a lot of energy, and it needs to be able to grab that energy. So energy needs to move around in some way. Life needs some building blocks to like build and grow. And so like you, it needs like food to eat, to make building blocks, to make more you. And then life needs water to help move that energy and move those materials that it eats to proper places in its body to grow. And so on Jezero, what I am seeing, lots of sign that water used to be there. This is a beautiful crater. But friends, do you see this? It's like a little squiggly line coming all the way down. It gets thicker and thicker near the end. And then it breaks those crater walls and fans out like a delta, like a riverbed. Is it water? We think that this used to be a giant river flowing into this crater, forming, oh friends, look at this. You see how the shape changes and the texture changes? It becomes all squiggly. It's almost like it has a coastline underneath. We think Jezero Crater was formed by a crater and then filled up to be a lake, just like Lake Washington. Why is this image gray and not red? That is a fantastic question. Thank you for sharing it. Sometimes when we take pictures of things, we really like to see the color. Color is really important for us to identify things. But when we're looking up from far away and we want to look at a lot of detail and see a lot of contrast, that's when we look at pictures in black and white only. That helps us be able to see different elevations and different contrast things. So if everything was red, I might miss that little rock right there or that little rock right there. But if I look at things only in black and white, then it's easier for us to see these tiny little objects. Oh, wow, Paulina, that is a great observation. It does look like a river. In fact, we sent a probe to kind of give us a different image and the type of color that you and I can't even see to get a good, clear idea of what this looks like. That's what Jezero Crater looks like if we really just look at the river features that Paulina was talking about. Oh, wow. You can see the water just kind of flow out of that cliff face and just kind of spread out. And it's still purple all the way around as it kind of filled in an ancient lake. We could see different elevations as the water moved up. And maybe the water went up and down, just like Lake Washington. Sometimes its levels go up and down. And it's environments like those in the long, long past that a thing like a tardigrade would have loved to be at. So maybe there's something in the long, long past and Mars history that used to live at the border of this lake too. Now, friends, like I said, that's a mission that we are sending tomorrow, but it's not the only mission that we have sent to Mars. It's not the only rover we have sent to Mars. There's another one called Curiosity. It was launched in 2012, and it is still driving around, roving and roving on the red planet all of these years later. It landed in this little mark right there. This is called Gale Crater. This is a crater that was formed by an asteroid impact. The asteroid impact was so hard that the center of the crater popped back up and formed a mountain. It's a mountain we call Mount Sharp. This is where Curiosity landed. Its mission wasn't to look for life, but it was to look for where we think life could have lived or habitable places for life, and signs that water used to be there on this crater. That's why some of these images look a little bit more detailed than others. This is around where Curiosity landed. Well, it's nice to get this upper view, but let's go ahead and get a view of what things look like from Curiosity's perspective. Friends, look at this. This is Curiosity. It's a beautiful website for adult friends. Go ahead and copy this down because this is based on real data from Curiosity, a car-sized rover that is still driving around on the red planets. It landed in 2012. It was only supposed to last 2 years, but it's been lasting, well, I don't know, since last week. It's gone over 2,900 days on Mars, still traveling around. What I really liked about this feature is I could actually explore different elements and get a Curiosity's perspective of what it was, what it sees on the red planet. For example, friends, do you see how the sky? Well, the sky's not gray, blue, like on planet Earth. The sky on Mars is brown. It's like all of that rusty stuff that's on the ground has been kicked up in the sky. That means the sunsets on Mars, they're actually blue. That's really weird. I really like this feature because I could also navigate around at the different cameras and angles that Mars, the Curiosity used to actually see anything. Its mast, its top cameras is the size of a human adult so that we have a human's perspective of what it's like to be on the red planets. And then one of my favorite things is that you can interact with it. So I can move its robotic arm, Molly, just like Curiosity does. And I can move it around to kind of get the same images or different images, just like Curiosity did. So let's go ahead and move down to Molly, that hand lens mirror. And if we want to get a close-up vision, I will move down the arm and I would twist it around. All right, that's a little fuzzy. That must be the atmosphere. There's the ground. Uh-oh. Apparently, friends, I'm not a very good driver of a remote control car on Mars. I think that this might be something that you're going to have to try at home. So if you can't stay up tonight to look for Mars, that's okay. It's going to come out earlier and earlier, later on this year. So in the meantime, if you want to explore more about some space in Mars, Zeta has put the link in chat so that you could actually interact and drive around a rover, just like the rover that is going to be launched tomorrow. One thing about driving around a rover is that you have to do it in steps and stages. For example, one of my favorite things that Curiosity did was that it took a selfie. And I want you to look at all of the steps and stages it takes even to take a selfie from space. All right, so the rover is driving really, really fast. It goes really, really slow. if you can watch my fingers, this is about how fast it actually travels. Even though it's been up on Mars for over 8 years, it's only actually traveled about 13 miles, about half of a marathon. There's some adult friends out there running marathons a lot quicker, a lot faster than Curiosity. Curiosity, it takes it 8 years just to travel half of an actual marathon. But it went to the special space, and basically it uses its own cameras to kind of look at itself, kind of monitor how's it doing, how's it feeling. For example, there was one rover, a previous rover that, well, it broke a wheel, and so it was dragging around like it was a broken leg. Then it uses Molly to actually get some images of what it looks like. Watch its arm and see how only certain parts of it move at a time. Then it starts scanning itself to see different elements, particularly like the wheels and the lenses. Just look how slowly it moves, moving one joint at a time. Great science in the city last week about Mars rovers. There was a great science in the city last week about Mars rovers and all the great missions that we send to Mars. There's a lot to explore about the red planet. And one of my favorite things about that science in the city is that they really connected Mars to what's going on to planet Earth. You see, with all of the look for life and the different places in our solar system, whether it be Europa and underneath that sea, or Enceladus and Titan going around Saturn, or even looking for ancient life on Mars, the truth of the matter is we only have one example of life in our universe. There's a selfie on a different planet, all done by a robot in outer space. But like I said, there is only one example of life in our solar system. One example that we can use to really explore what it is like to live on a planet. And that's this planet right here. This is your home. This is where all of the life is, the only example that we have of life. And so the more that we study those other planets, the more we study about our own planet and what is really needed to take care of it, to take care of your home. All right, everyone. It was a lot of fun. I am glad that you are roommates with tardigrades on planet Earth. Think of a lot more questions for us to explore. And tomorrow morning at 7:30 Florida time is the rocket launch for Perseverance and Ingenuity. Go ahead and watch the recording on YouTube when you actually wake up. In the meantime, think about more questions that you would like to share during our planetarium tours. I am really enjoying this, and I really appreciate all of the great observations Polina and Chris and Andrea and a lot of my other friends shared with us today. Huge shout out to Jack and his tiger prints, his tiger stripes, Judy, Chris, Laura. Thank you all so much for sharing. Keep exploring the nighttime sky. And when it gets dark out, look out for Jupiter and Saturn and watch for that mission to Mars. Thanks, everybody. Oh, and definitely look at the chat feature and fill out that survey. Help us learn more about these programs so that we can share them out with a broader community. Help us continue to fund these programs. Visit pacsci.org/support to donate. Any little help happens. Big shout out to Shania. Thank you for joining us. I really appreciate all of the fun. The more that we learn from all of you about what you like, the better that we can support schools this year, particularly as most of King County school districts are going virtually. And we would love to be supporting those educators, those students, and those parents this year with these virtual field trips and virtual planetariums. So the more that we learn from you and the more support that we get, the easier it is for us to support the broader community. In the meantime, have fun playing with that robot and keep an eye out in the nighttime sky. Thank you, everybody. Live from Curiosity Studios at Pacific Science Center in downtown Seattle. This is Michael, your backyard astronomer, signing off. Bye.